Imagine you have just bought a brand new Wi-Fi router. On the box, the numbers look huge. Gigabit speeds, new technology, lower delay, stronger coverage, support for Wi-Fi 7. It sounds simple. Plug it and turn it on, and your whole home should become a fast wireless zone. So you place the router in the living room. The lights turn on. Your phone shows full Wi-Fi bars. Everything looks perfect. Then you walk into the bedroom. The video starts buffering. Your video call freezes. Your online game suddenly lags. Your security camera drops offline for a few seconds. And the question appears, if the router is so fast, why is your Wi-Fi still slow? Many people think slow Wi-Fi has one simple cause. Maybe the router is weak. Maybe the internet company is bad. Maybe the device is too old. Sometimes that is true, but most of the time, the real answer is hidden inside the invisible path of the signal. Wi-Fi is not magic internet floating evenly through the air. Wi-Fi is radio. It leaves the antenna of your router. It travels through your home. It hits walls. It bounces off furniture. It passes near metal, glass, water, people, and other electronics. Then, after all of that, it still has to reach your phone, laptop, television, or camera clearly enough to be understood. That journey is where speed disappears. The first thing to understand is this. The number on the router box is not the speed you are guaranteed to get. It is usually a maximum possible speed under very good conditions. Close distance, clean signal, little interference, few obstacles, compatible devices, and a network environment that is almost ideal. But a real home is not ideal. A real home has walls, concrete, brick, wood, glass, doors, floors, mirrors, televisions, refrigerators, pipes, cabinets, fish tanks, people walking around, and neighbors with their own routers. To Wi-Fi, your home is not empty space. It is a maze. Every wall can weaken the signal. Every metal surface can reflect it. Every large object can scatter it. Even the water in a fish tank, or in the human body, can absorb part of the energy. So the signal that leaves your router is not the same signal that reaches your bedroom. Some of it gets absorbed. Some of it bounces away. Some of it takes a longer path. Some reflections meet each other and make the signal worse. This is why moving just a few meters can change everything. Near the router, your phone may receive a strong and clean signal. Behind two walls, the signal may still exist, but it may be weak, noisy, and hard to read. That is also why Wi-Fi bars can be misleading. Full bars do not always mean fast internet. They only tell you that your device can hear the router. They do not tell you how clean the signal is. They do not show how much interference is nearby. They do not show how many devices are waiting to use the same air. And they do not show how many data packets have to be sent again. To understand this better, think about the three main Wi-Fi bands: 2.4 GHz, 5 GHz, and 6 GHz. The 2.4 GHz band is like an old road that reaches far. It often travels through walls better. It can cover more distance. It is useful for devices that are far away from the router, but it is also crowded. Many older Wi-Fi devices use it. Some other household devices can create noise near it, and there are fewer clean lanes available. So 2.4 GHz can reach far, but it is often slower and busier. The 5 GHz band is like a wider and faster road. It can carry more data. It is often better for streaming, gaming, and video calls when you are not too far from the router. But it usually does not travel through walls as well as 2.4 GHz. Then there is 6 GHz. This band became important with newer Wi-Fi generations, including Wi-Fi 6E and Wi-Fi 7. 6 GHz is like opening a new level of roads above a crowded city. There is more space. There can be wider channels. And in many places, there are fewer old devices fighting for the same lanes. When you are close to the router, 6 GHz can be extremely fast. but it is not a magic solution. Higher frequency signals usually have a harder time passing through walls and long distances. So if you are far from the router, or behind several walls, 6 GHz may not be the best path. This is one of the biggest misunderstandings about Wi-Fi. A bigger number is not always better. 6 GHz can be faster in clean conditions. 5 GHz can be a strong balance between speed and range. 2.4 GHz can be slower, but it may survive better at longer distances. A good router is not just a box that shouts louder. It is a system that tries to choose the right path for the right device at the right time. Now let us look at what actually moves through the air. When you watch a video, the router does not send the video like one smooth stream of water. It cuts the data into small pieces. These pieces are called packets. Each packet is turned into a radio signal. The router sends it through the air. Your device receives it. Then your device turns it back into data. If the packet arrives clearly, everything feels smooth. But if the signal is weak, noisy, or distorted, the packet may contain errors. When that happens, the network may need to send the same packet again. You do not see this process. You only see the result. The video buffers. The game lags. The website takes longer to load. The call freezes for a moment. Underneath, the Wi-Fi system is repeating work. The more packets it has to resend, the slower the real speed becomes. And here is the next important point. Wi-Fi is shared air. The space around your router does not belong only to your network. In an apartment building, there may be dozens of routers nearby. Your neighbor has one. The apartment above you has one. The apartment below you has one. The office next door has several. Each router may be talking to phones, laptops, televisions, cameras, speakers, game console, and smart home devices. All of them are trying to use parts of the same invisible radio space. This is why Wi-Fi is different from a cable. With an Ethernet cable, the data has a dedicated path. With Wi-Fi, devices have to share the air. A good way to imagine this is a crowded room. If one person speaks, everyone can hear clearly. If 10 people speak at the same time, the room becomes noisy. If everyone keeps interrupting each other, the conversation slows down. Wi-Fi has rules to avoid total chaos. Devices take turns. They wait. They listen before they transmit. They try not to talk over each other. But waiting takes time. And when many devices are active at once, each one gets a smaller share of the air. This is why your Wi-Fi can slow down at night. Not because the router suddenly became weaker, but because more people may be streaming, gaming, calling, uploading, and downloading at the same time. In the past, one home might have had only a laptop and a phone. Today, a home can have phones, tablets, laptops, smart TVs, security cameras, speakers, game consoles, watches, thermostats, doorbells, light bulbs, and robot vacuums. The problem is no longer just, do I have Wi-Fi? The problem is, can my Wi-Fi manage all of this at once? This is where new Wi-Fi generations try to help. Wi-Fi 7 is not only about making the signal stronger. It adds new tools. One tool is wider channels. A wider channel is like a wider road. If the road is clean, more data can pass through at the same time. Wi-Fi 7 can use very wide channels in the 6 GHz band, when the country, router, and device all support it. But a wider channel is not always better. A wide road is useful when it is open. In a noisy environment, a very wide channel can also collect more interference. Another tool is more advanced signal coding. In simple terms, Wi-Fi can place more information into each tiny change of the radio wave. This can increase speed when the signal is very clean, but it only works well when the device is close enough and the signal quality is high. If you are far away, or there is too much noise, the system has to use a simpler and more reliable method. That means lower speed. Then there is multi-link operation. This is one of the most interesting ideas in Wi-Fi 7. Instead of relying on only one connection path, a device may be able to use more than one link across different bands or channels. Think of it like a driver who can choose between several roads instead of being trapped on one highway. If one road is busy, another may help. If one path has delay, another path may be better. In some situations, this can improve speed, lower delay, and make the connection more stable. But again, there is a condition. Both the router and the device must support it. If your router is Wi-Fi 7, but your phone or laptop is older, the older device cannot use every Wi-Fi 7 feature. This is another reason people get disappointed. They buy a very advanced router, but most of the devices in the home still speak an older Wi-Fi language. The router may be ready for the future, but the devices may not be. There's also one more limit that people forget. Your Wi-Fi speed and your internet speed are not the same thing. Wi-Fi is the wireless connection inside your home. Your internet plan is the connection from your home to the outside world. If your router can move data around your home very quickly, but your internet plan is much slower, then downloads from the internet are still limited by the plan. It is like owning a sports car, but driving it on a narrow road with a speed limit. The car may be capable of much more. The road is not. Now let us talk about placement. Router placement can make a huge difference. A router hidden inside a cabinet is already fighting a wall before the signal even enters the room. A router behind a television may be blocked by metal electronics and cables. A router placed on the floor sends much of its energy into furniture, people, and nearby objects. A router placed at one far corner of the home has to push the signal through the entire building. The best position is usually open high, and close to the center of the area you want to cover. Not hidden. Not behind large electronics. Not inside a metal shelf. Not buried under decorations. Wi-Fi needs space to breathe. Mesh systems can help, but only when they are placed correctly. Many people put a mesh node in the room where the Wi-Fi is already terrible. That sounds logical, but it often fails. A mesh node cannot repeat a good signal if it only receives a bad one. It should be placed where the signal from the main router is still strong enough. Then it can extend that good signal farther. If the mesh node is too far away, it may simply repeat a weak and unstable connection. For larger homes, the best solution is often wired backhaul. That means the access points are connected by Ethernet cables behind the scenes. The devices still connect by Wi-Fi, but the access points talk to each other through a stable cable. In other words, sometimes the best way to improve Wi-Fi is to use a wire in the places that matter most. Now let us return to the original problem. You bought a very fast router, but it is sitting in the corner of the living room, behind a television, near other electronics. Your bedroom is behind two walls. Your neighbors are using nearby channels. Your laptop supports an older Wi-Fi standard. Your cameras are uploading video. Your TV is streaming. Your phone is backing up photos. And several smart devices are connected all day. In that situation, the router is not simply failing. It is working inside a difficult battlefield. The signal has to pass through obstacles. It has to avoid noise. It has to share airtime. It has to resend damaged packets. It has to slow down to stay reliable. And it has to serve many devices at once. By the time the data reaches your bedroom, the real speed may be much lower than the number printed on the box. So what can you do? First, place the router better. Put it in an open area. Place it higher. Keep it away from large metal objects. Avoid hiding it in cabinets. Try to keep it closer to the center of your home. Second, choose the right band for the right job. Use 2.4 GHz for distant or low-speed devices. Use 5 GHz for faster devices at medium range. Use 6 GHz for very fast connections near the router or access point. Third, check your devices. A new router cannot make an old phone use new Wi-Fi features. Both sides need support. Fourth, use mesh carefully. Do not place mesh nodes where the signal is already dead. Place them where the signal is still good, so they can carry it forward. Fifth, use Ethernet when possible. For game console, desktop computers, smart TVs. or mesh backhaul. A cable can remove a lot of wireless pressure. 6. Update your router. Modern routers are not just hardware. Software controls channel selection, security, device management, mesh behavior, and bug fixes. A firmware update can sometimes improve stability. And finally, stop judging Wi-Fi only by the biggest number on the box. Look at stability. Look at delay. Look at coverage. Look at how many devices are connected. Look at where the router is placed. Look at the shape and materials of your home. Because the future of Wi-Fi is not only about higher peak speed. The real goal is a connection that feels fast everywhere. A video call that does not freeze. A game that does not lag. A camera that stays online. A smart home that responds when it should. A laptop that keeps working when you move from one room to another. This is why future Wi-Fi will focus more and more on reliability, lower delay, better sharing of air, and better coordination between access points. The real problem is not always that Wi-Fi is too slow. Sometimes the problem is that too many devices are trying to speak in the same invisible room. A fast router can create amazing speed under ideal conditions. But a good home network needs more than power. It needs the right location, the right devices, the right band, the right layout, and a smart way to share the air. So the next time you see a huge speed number on a router box, remember this. That number is only what the router may be able to do in the best case. Your real Wi-Fi speed is decided by the journey of the signal. From the antenna, across the room, through walls, around furniture, past interference, past your neighbors, and through every device waiting for its turn. Wi-Fi is not magic. It is a constant negotiation between radio waves and the physical world. And once you understand that, you stop asking only one question. You stop asking, how fast is this router? You start asking the better question. How will this signal actually move through my home?